Thank you for joining this lesson. We're going to discuss area approximation. Number 17, complete the table below for y equals to x squared minus 3x plus 5 in the range x between 2 and 8. Therefore, we have a table here, x and y. For every value of x, there is a corresponding value of y. At 3, we have 5. At 4, we got a dash. At 5, a dash. So that is what you're going to be filling. So we're going to substitute in the main equation here. In the place of x now, we substitute with 4. Therefore, we will start with 4 squared minus 3 into 4, then plus 5. This becomes positive 9. The next is a 5, so 5 squared minus 3 into 5 plus 5. This is going to be 15. At 6, we have 23. At 7, we'll start with 7 squared minus 3 into 7, then plus 5. This is going to be 33. Then at 8, we're going to have 8 squared minus 3 into 8, then positive 5. This is going to be 45. So that is the table now. It's now filled. Use in part B the trapezium rule with 6 stripes to estimate the area enclosed by the curve, x-axis, and the lines x equals to 2 and x equals to 8. Remember to subscribe to this channel and to share the link with friends. Before we go to the calculation, we must be able to state how area is approximated using the trapezium rule. This is given by half times h into, you open the small brackets, y naught plus yn, then plus 2 multiplied by y1 plus y2 all the way to the y just before the nth y. So that is the formula which we call the trapezium rule. In this formula, h is the interval between, or the length of these strips we are going to use. So a strip is running from 2 to 3. So this is the first strip. So we have a 1, 2, 3, 4, 5, 6. They are already 6 strips. You don't count the ordinates which we have calculated the values for. You just calculate the strips, and the strips, in case you had plotted this one, you will not count this one as the first strip. The first strip will be from 2 to 3. Therefore, it will be 1, 2, 3, 4, 5, 6. Now that we have the 6 strips, we should know that in the formula now, we just want to use h as the interval between the strips. So from 2 to 3, from 3 to 4, 4 to 5, and so on, we have a difference of 1 unit. Then we open the curl brackets. Y naught is the first value of y. Then yn is the last value, which is 4, 5. Then 2 multiplied by all the other y's now in between there, which include 5. This is a 9. This is a 15. 23 and 33. And 33. For those who might be having something to consult, there is a number on the screen. Kindly feel free to reach us. This is going to be 0.5. When you multiply a half by 1, it remains the way it is. Then we're going to have 48 plus 2 multiplied by everything here, which is going to be 2 by 5 plus 9 plus 15 plus 2, 3 plus 3, 3. This is going to give us 170. Therefore, 170 plus 48, then now we divide by 2, or rather we multiply by half. I'm going to get 109 squared units. Squared units. So that is the area using the trapezium rule. The next is find the exact area of the region given in B above. What you should do is that just before you calculate area by integration, that is exact area, this one is area by integration, you are supposed to sketch this curve and at least you try to see how it behaves. But now we can see for all the positive values of x, there are positive values of y. And this means from 2, the curve is just going to behave like this, just trying to sketch. So it means all the area for the curve bounded by the given values of x, 2 and positive 8, it means the whole area is above the x-axis. Now that the area is on the same side of the x-axis, then we carry out integration just once. Therefore, we're going to integrate from 2 to 8 the function, which is y squared minus x squared, x squared minus 3x positive 5 with respect to x. So we're going to integrate this function. Therefore, when we tend to integrate, the powers of x should increase in every term by 1. Then the new power divides that term. Therefore, x, which is squared, now becomes power 3, then divided by 3, minus negative 3x. Now x becomes squared. Then the new power, which is 2, now divides. So that we have 3 out of 2, and x is now squared, plus, when you see a constant, it means there is x power 0. That's why it is 1. So 3 power 0 now becomes power 1. X, which is power 0 at this point, now becomes power 1. And 1 divides. So that 5x over 1 remains the way it is. Then there is always the constant of integration that disappeared during differentiation. So this is 2. This is 8. Then now we can substitute 8 and later 2, and we subtract the two sides. Therefore, we're going to have 8 cubed out of 3 minus 3 out of 2, 8 squared plus 5 into 8 plus a constant minus, this is going to be, we start now with 2 power 3 out of 3 minus 3 out of 2, and this is going to be 2 squared, then plus 5 into 2 plus the constant here of integration. Then now we can work out this. 8 cubed out of 3. Then we subtract 3 over 2 into 8 squared. Then we add 5 into 8. Then we add 5 into 8. Let me work it out very fast. 8 cubed, I divide by 3. This is going to be 170. Then I subtract 3 out of 2 into, I square 8. Then again I add 5 into 8, which is 40. So I'm getting 114 and 2/3 plus a constant of integration, then minus, on the other side I begin with the 2 power 3, then I divide by 3, then minus 2 out of 3 into 2 squared, then I add 5 into 2. This is going to be 6 and 2/3 plus a constant of integration. In this case, I'm going to have the constant of integration cancelling, then 114 minus 6, because a third or 2/3 is going to cancel in both cases. Therefore, 114 minus 6 gives us exactly 108 square units. By integration, I'm getting an exact area of 108 square units. So finally, I am to get now the percentage error in the area when using the trapezium rule. Percentage error is given by, first of all, getting the error, which is going to be the difference between the two areas, 109. That is the area by trapezoidal rule, minus the exact area. Then now I divide with the exact, and because it is percentage error, I'll multiply it by 100. Therefore, 1 times 100 and divided by 108. This is going to be 0.9259%. So this is the percentage error in the calculation of the area to 4 significant figures. Thank you for following. Subscribe and share.